Yes, hello everyone. My name is Roger James, and I'll be talking about fire suppression on weather decks. Um, uh, I am the Director of International Sales for Unifire of Sweden. This is the problem we're addressing, which was laid out, I think, well for everyone. I have a lot to cover, so I'm going to go through these fairly quickly. First, I'll give an introduction of sort of some of the takeaway conclusions from the research and development we've done in the LASH Fire context. I'll talk about then the objectives that we were given, the solutions we came up with. I'll talk more about the fire monitors themselves, and then we'll get into, I'll show some photos from large-scale testing that we did for the suppression, and then also of autonomous systems. And then I'll wrap it up and conclude again. So some of the takeaways, first of all, one small 2-inch remote controlled fire monitor, as you see here, with a modest flow of 1,250 liters per minute at 5 bars can effectively suppress and contain a large fire. The primary goal is to suppress and contain, and then of course, if we can extinguish, all the better. Also, 2 fire monitors fighting simultaneously from opposing angles is much more effective, and in some tests we're even able to extinguish large fires. Next, because the systems are relatively small, using a 2-inch monitor at relatively low flows and pressures, we're able to reduce the costs. Smaller pipes are required, smaller pumps, and so on. So that keeps costs under control. Next, rapid intervention is really key. So we want to minimize the time to detect and then commence suppression as much as possible. Also, autonomous systems can very rapidly detect a fire, locate the fire, and suppress it with the fire monitors. This brings a big advantage to be able to react very quickly to a fire on the weather deck. So the objectives that we looked at were, first of all, quick system activation and suppression, then also the safe controlling of the monitors by remote control. Next, high coverage of the deck. And then all of the equipment needs to be able to withstand the harsh environment. We want to also minimize cost to the maximum extent possible. And we also want to bring in state-of-the-art technologies to help with the problem. So the solutions that we came to and developed and tested were fire monitors, so remote controlled, also looking at semi-autonomous and fully autonomous remote control systems. And then we also, another partner developed a compressed air foam system, which unfortunately during the testing malfunctioned, so we don't have any conclusions from that. And for that reason, I won't talk about that in the rest of the presentation. So looking at the fire monitors, we are recommending 2-inch remote controlled monitors. They should be made, obviously, of a material that's appropriate for marine environments, such as stainless steel 316L or other equivalent. We are recommending a modest flow of 1,250 liters a minute at 5 bars of pressure. And again, that's to keep all of the system requirements down to a minimum while still being able to provide effective suppression. All of the monitors need to be, as we're recommending, not the IMO anticipated language that was introduced at the beginning of the talk, but from our research and development and what we're recommending to the IMO through the LASH Fire project is that the monitors all be able to be remote controlled. And there's a number of reasons for that. First of all, by having them remote controlled, you allow the maximum flexibility in terms of placement to put them up high and in locations where they can adequately suppress a fire on the weather deck, especially given the very tight packing of the cargo. Also, you can have a faster response. A human can pick up the remote control and immediately start suppressing. rather than having to get to a mechanically operated monitor very often to get dressed and air supply and so on and so forth, which dramatically reduces the response time. Also, from a safety perspective, to be able to keep a safe distance away from the fire and still be able to operate that. And then by not requiring these structures to get up to a physically manually operated monitor, and for the other reasons, we're able to lower the overall cost. So we're recommending that all systems be remote controlled, as I just mentioned, but also we have looked at and developed and allowed for semi-autonomous systems, which allow a human to start the system, but be able to record and play back a spray pattern while they continue on to other suppression activities or help with other emergencies. Also, fully autonomous systems that require no human intervention whatsoever, which can automatically and very quickly detect a fire and suppress it. We also are recommending that all locations of the deck be accessible by at least 2 monitors positioned at opposite sides of the deck, and that the fire pump be able to supply at least 2 monitors simultaneously. Also, the monitors should be placed high up in order to give them the ability to properly suppress the cargo, including in the middle. As you can see, as you know, the decks get very packed, and you need to get them up above them to have any sort of an angle of attack to suppress them. So now I'll go through some of the tests that we did. Essentially, we did a large-scale fire test to see the effectiveness of the suppression with water. And we did different combinations. So we did them with 1 monitor at a time, and then we did 30-second pre-burn to simulate a rapid autonomous response. And then we also did a pre-burn of 300 seconds or 5 minutes to simulate a sort of a human intervention with a 5-minute delay, and see how the system was able to, or how the monitors were able to suppress a fire under those conditions. So we did that with 1 monitor, and then we also did it with 2 monitors at different angles, and again with different delay times. And then in a separate set of tests, we looked at validating an autonomous system to see if it could detect and aim, and I'll get into that also. So the setup was really to mimic a freight truck on a weather deck and sandwiched between 2, in this case, containers, but to simulate also 2 other freight trucks. This was the actual setup, and these containers contained many thermometers inside to measure the tests, the temperature buildup, and so forth. There were 224 pallets in each of these tests, so they really led to massive fires, plastic pallets on the top, and then idle wood pallets beneath. The monitors were mounted up high according to the recommendations. Here's a view from behind one of them looking down at the test scenario. So now I'll show you a few pictures of 1 monitor, and in conclusion, 1 monitor in all of the tests was able to effectively suppress and contain the fire, which is our primary goal. And you can see the pre-burn times led to the 300 seconds especially led to an absolutely massive fires. Very, very interesting results and very effective suppression. And I have a video, and I'll be happy to share links with that after the webinar. Anyone who's interested can see that on LASH Fire and on our website as well. Just some more images of the single test, single monitor. And then here's several images of the 2 monitors. And in conclusion, with 2 monitors, we saw far superior suppression, much more rapid cooling, and just an overall much better response. And in fact, several of the tests with the 2 monitors were able to actually extinguish a very large 300-second pre-burn test very quickly. So very, very effective with 2 monitors. Again, to summarize, 1 monitor is successful, able to suppress a fire, but not able to extinguish them. Still, that's a success in terms of what we're after. Early intervention was much better than later intervention. So the sooner you can get to it, the better. Also, tests using the 2 monitors was superior to all of the tests using 1 monitor. And again, the early intervention, 30 seconds, was much better than the 300 seconds. Now, turning to fully autonomous systems, we tested, so Unifire developed the Flame Ranger system, fully autonomous system, that is essentially combining the fire detection with the aiming of the water monitor by means of using advanced electronic hardware and software. And the technology is really coming a long way on the market, and these systems are now becoming more and more ubiquitous and becoming more and more advanced. The basic idea is you bring in signals from a fire detection technology, and various technologies can be used, including the ones that Rick Jeffress mentioned earlier. So you want to detect, you want to be able to locate that fire, you need to know where it is. You then want to aim the fire monitor autonomously and suppress that fire all within seconds. So that's what the objective of these tests was, to see if an autonomous system on a mimicked weather deck is able to quickly detect multiple separately placed fires, able to determine the 3-dimensional position of the fires, and able to accurately guide the water stream to those fires. So the setup was a 30 by 50 meter area, again, mimicking a weather deck. We had 2 systems set up on opposite sides, and each system had 2 flame detectors in order to be able to locate the fires in 3-dimensional space. And then fires were placed at different areas on the grid, and a number of tests were conducted. This is what the monitor and the detectors looked like. We used remote-controlled gas burners to simulate the fires and be able to turn them on and off in different locations. And there was also a wind machine to simulate wind and rain and fog to see the effects on both the suppression and also the detection. So again, fire detection testing to see the time and detection accuracy. Then also the precision of the ability to aim the monitors and accurately move from one fire to the next. And then also to test the operation of 2 independent systems simultaneously, and then to look at the influence of wind on the water stream and also the influence of rain and fog on the fire detection. And this is what the actual test looked like. And again, we have video of that that we can share with you if you're interested. Very, very interesting tests and how the system was able to move from one to the next. Here's the wind machine and what that simulation looked like. And the results were as follows. So in all of the tests, in all fire positions, the system was able to detect in under 10 seconds. The fire detection was not affected by the simulated rain or fog. The system did accurately find the 3-dimensional size and position of every fire. The system accurately aimed the water streams of the monitors to the fire's locations. The monitors oscillated over the fires to provide water over a larger area than the fire itself using intelligence. The system moved from one terminated fire to another newly ignited fire in under 10 seconds. In the test, the test with 2 systems show that both systems were able to hit the fires, and that the flow of 1,250 liters a minute at 5 bars of pressure was enough to get to the very corners of the test area of roughly 40-meter reach. And then last, wind will affect, in relatively short distances, it didn't affect it too much, but in actual conditions, the wind will affect the stream, especially the farther away it is. And therefore, by having 2 monitors covering all positions, you're not only getting much better suppression, but also maximizing the chance of being able to suppress that fire even in high winds. If wind's affecting one, the other one should still be able to hit it. So just to conclude, they should be remote controlled. 2 monitors should be able to cover the whole deck at relatively modest flows and pressures. Costs are reduced by having them remote controlled and relatively small. The faster we commence suppression, the better. And autonomous systems are now available that can rapidly and autonomously detect a fire and suppress it, which gives big advantages in terms of getting to that fire rapidly for a relatively low additional cost. So that's it. Thank you very much.